Assalamualaikum warahmatullahi wabarakatuh. We will continue with our final lecture on pharmaceutical calculation. So in this lecture, we will discuss on MWQ, the minimal weighable quantity or the aliquot method. Okay, so the aliquot method is a useful method in the event whereby we have to weigh a very small amount. Okay, all equipment will have a minimum weighable quantity or MWQ. As for the weighing balance in the lab, the MWQ is 200 milligram. Means that, what does this mean? It means that the weighing balance that we have in the lab can only weigh something or powders or ingredients at a bigger amount than at a higher quantity than 200 milligram. If the prescription asks you, or if the product asks you to measure something that is less than 200 milligram, the weighing balance cannot weigh that accurately, okay, because the minimum weighable quantity is 200 milligram. That's the minimum amount that can be weighed by using the weighing balance. So what should you do if you need to weigh something smaller or something less than 200 milligram? So this is when we will use the aliquot method. And this is the same as measuring liquids. As an example, if you need to measure something less than, let's say, 1 ml, but you only have a measuring cylinder of 1 ml, you cannot measure something less than 1 ml. So what should you do? So in such cases, we have the aliquot method for measuring liquid. Okay. So the aliquot method is useful for both liquid and also solid. So we can use the method for measuring and weighing of substances. And what is the meaning of aliquot actually? It means that the fraction or portion or part that is that contain the exact amount or the exact number of times in another. So the definition is a bit confusing, but I think you get the meaning that I want to tell you. Means that we will use this aliquot technique to enable us to measure the exact or a smaller quantity of substance less than the minimum weighable or minimum measurable quantity by our equipment that we have in our lab. Okay, so weighing by aliquot, if we say weighing means it's something in gram or milligram, and we need to use the weighing balance. So if an example, if you look at the image here, if let's say you want to weigh something at 200 milligram, okay, sorry, I'm sorry, if you want to weigh something 5 milligram, okay, you cannot weigh by using the weighing balance that we have, because the minimum quantity is 200 milligram, but you want to weigh 5 milligram. So what should you do? You would need to weigh 200 milligram, and then you do some kind of dilution so that at the end you can obtain the 5 milligram that you need. So I give you an example here. Okay, so if you need 5 milligram, but you have to weigh 200 milligram because the MWQ is 200 milligram. Okay, I will show you the example. Okay, so you want only 5 milligram, but the MWQ is 200 milligram. Okay, so the first step that you need is that, of course, you would use the weighing balance and you would weigh your powder 200 milligram. Now, the 200 milligram is 40 times higher than the amount that you need, right? You weigh 200 milligram, but this is 40 times bigger than the amount that you need. So what should you do? Okay, now we will do some kind of dilution with a diluent, okay, and at the end we will have a mixture of the the substance that we want mixed with the diluent. Okay, 40 times is also equal to 5 times 8, right? This is also equal to 40. Okay, so now this is what we need to remember at this point. Okay, next, you have your 200 milligram powder here. Okay, and then what you need to do, the first step is to dilute it with a diluent 5 times. Okay, times 5 equals to 1000 milligram. So what should you do at this point is that you have your 200 milligram of powder of the drug that you want to dilute, and you would add a diluent 5 times the quantity. Okay, because we are referring here to 5 times 8, the dilution times here. Okay, 5 times, and then you would have a 1000 milligram of powder. Means that what should you do? You take 200 milligram of drug, you add 800 milligram of diluent, equal to 1000 milligram. Okay, from this 1000 milligram, if you weigh 200 milligram from the 1000, okay, you would have, if in 1000 milligram you have 200 milligram of drug, how much of drug would be available in the 200 milligram? There would be 40 milligram of drug. Okay, in this 40 milligram of drug, actually there is 40 milligram of drug plus 160 milligram of diluent. Okay, next, the 200 milligram will be further this 200 milligram, okay, this 200 milligram of mixture, okay, that contain all this, okay, will be further diluted. Okay, will be further diluted. How many times? The second dilution would be 8 times. So the 200 milligram would be further diluted 8 times to give us 1600 milligram. So it means that the 200 milligram would be added with 1400 milligram of diluent to give us 1600 milligram of mixture. Okay, so from this mixture, okay, in this 1600 milligram of mixture, you have you have 40 milligram of drug. Remember, because this would refer to here again. Okay, because the 40 milligram of drug in the 200 milligram of mixture at the first time dilution was added with 1400 of diluent. Okay, and bringing the total to 1600, and in this 1600 there is 40 milligram of drug. So if we take 200 milligram from the mixture here, okay, how much drug will there be? 200 milligram times 40 milligram divided by 1600 milligram. (200) times 40 divided by 1600. Here you would have 5 milligram of drug. Remember, at the beginning, you want to weigh 5 milligram, right? Your aim was to weigh 5 milligram of drug. But as it's not possible because of the MWQ of the weighing balance, so we use this aliquot method in which we dilute it with a diluent, and at the end, at the end of the dilution method, you would have your 5 milligram of drug. So, so what is a diluent? A diluent can be any powder that does not disturb the function of the drug. As an example, the common diluent that we use are such as lactose. Lactose is a kind of sugar, okay, and it is easily handled. So we normally use lactose as the diluent. It means that if we want to simplify the step that we did just now, okay, if we want to simplify it, you have to weigh 5 milligram of powder, but you can't weigh it. You have to weigh 200 milligram. The 200 milligram is equal to 5 milligram times 40. Okay, so the dilution would be 40 times. And this 40 times is actually equal to 5 times 8. Okay, so the dilution can be made 2 times dilution. Okay, 5 and 8. Now, the 200 milligram that we weigh, okay, the 200 milligram of drug that we weigh, okay, we would dilute it 5 times into 1000 milligram, okay, in which the 200 milligram contain the drug from here, and we add with 800 milligram of a diluent. Okay, in this 1000 milligram, there would contain 200 milligram of drug. So, if we take 200 milligram from here, why we take 200? Because it's the minimum weighable quantity. So, from the 1000 milligram, we weigh 200 milligram from the mixture. And in this mixture, there would be 40 milligram of drug plus 160 milligram of diluent. So, this 200 milligram of mixture will be subjected to second time dilution. Okay, in the second time dilution, in the second dilution, what will happen is that the 200 milligram that we have, remember, there's 40 milligram of drug and 160 milligram of diluent, right? So the 20 milligram will be further diluted 8 times. Why 8? Because it's from here. Okay, we'll further dilute it 8 times into 1600 milligram. So what will happen here? The 200 milligram, okay, will be added with 1400 milligram of diluent. Okay, now we have 1600 milligram of diluent. In this 1600, we have 40 milligram of drug from here, right? The amount of drug would remain the same, 40 milligram of drug plus 1560 milligram of diluent. Correct? Okay, so now if in 1600 milligram of drug you have 1600 milligram of drug of a mixture, of the mixture, right? Here, okay, contain 40 milligram of drug. So if we take 200 milligram of the mixture, there would be 5 milligram of drug in the mixture. So at the end, actually, we have a powder mixture of 500 milligram of drug and 195 milligram of diluent. Okay, that's how we do the aliquot method. So it's a bit confusing at the beginning, but please try to understand it. And if you have any problem, I will explain to you further. Okay. Okay. Okay, so that is weighing by aliquot. So measuring by aliquot means that we use a measuring device. As an example, a measuring cylinder. So what should you do? The first step is to select a multiple of the desired quantity that can be measured with the required precision. Dilute the multiple quantity with a compatible diluent, usually a solvent for the liquid to be measured, and then measure the aliquot of the dilution that contain the quantity originally desired. So I give you an example. So the formula require 0.5 milliliter of hydrochloric acid, but you don't have a pipette, let's say, a suitable pipette to measure the 0.5 ml of hydrochloric acid. So you can use a 10 milliliter graduate calibrated from 2 to 10 ml in 1 milliliter division to measure out the 0.5 milliliter of hydrochloric acid. So let's say we use 4 as the multiple. So 4 times 0.5 is 2 ml of the acid. So you measure the 2 ml of the acid. Because you can measure 2 ml, right? Because you have the 10 milliliter graduated cylinder. And then you dilute with 6 ml of water. The final volume would be 8 ml. And then you can measure 1/4 of the dilution, or 2 ml of the dilution, which will contain the 0.5 ml of hydrochloric acid. So let us see. How can we do that? Okay, so as an example, you need 0.5 ml of HCl. You only have a measuring cylinder, 10 ml measuring cylinder. The 10 ml measuring cylinder, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, but you can't measure 0.5 ml because the smallest calibrated is 1 ml. So this is the smallest. You can't measure 0.5 ml. So what should you do? Okay, let's say we choose, you have to choose a multiplication that is easier to measure. As an example, here I choose 4 times. So this would be 2 ml. So at the end, we will measure 2 ml out from the measuring cylinder. Okay, now you pour in 2 ml of HCl into the measuring cylinder. Now you have 2 ml, and then you would dilute it 4 times, right? So you would dilute until 8 ml, because 4 times it will be equal 8 ml. So you would add in 6 ml of water. Okay, you add in 6 ml of water to reach 8 ml. So now, in this 8 ml, you would have 2 ml of HCl. So if you want 0.5 ml of HCl, so how much should you measure? 0.5 times 8 divided by 2. So it should be 2 ml. So you can measure the 2 ml out. The 2 ml would contain 0.5 ml of HCl. Okay? Okay, so I give you some example and also the answer. Okay, you can try to do the example. Okay, and if you have problem, you can always ask me. Okay, there's another part in calculation, which is the pediatric dose calculation. So pediatric means children. Yeah, the dose for children are usually different than the dose for an adult. So as pediatric or children is a special population, the medication dose should be given very carefully, and because they have a smaller body size and smaller body surface area, the amount and quantity of the medication that they need would be much less than the dose needed by an adult. So there are different methods for dose calculation for pediatric. So it can be basically divided into calculation based on age, or based on weight, or based on body surface area. There are different formulas. Okay, as an example, if we refer by age, there are 3 formulas that can be used: the Young's rule, the Dilling's rule, and the Frye's rule. Basically, the dose would depends on the age of the child, with reference to the dose by for the adult. The calculation will give not exactly the same quantity of drug, so it is very tricky if you need to calculate for a very sensitive drug. Sensitive drug, I mean the drug that is that can easily give a toxic effect if we give a higher dose, okay, than expected. So the calculation by age is sometimes not the accurate way to determine a dose for children. But nevertheless, I want you to be aware of the different method of dose calculation. So here I give you some example. Okay, the same question, but if you calculate by using the different rules, the amount of drug would be different. Okay, and the difference can be quite obvious between the Young, Fried, and Dilling's rule. Okay, the Dilling's rule will give the lesser quantity of drug as compared to Young's and Fried's rule. So by body surface area, we usually would refer to body surface area of the child with reference to the adult dose. So we need to determine the BSA, or body surface area of the child. This equation can be used. Patient BSA equals to patient's height and patient weight. But we have to calculate correctly, okay, to with reference to the patient's height and weight. So we have to measure the height and weight correctly. But we can also use a nomogram. Okay, if you see the height of the patient is, let's say, 100 centimeter, and the weight is 15 kilogram. So by drawing a line straight from the height to the weight, we can determine the body surface area of the child. So this is a much simpler way to determine the body surface area of a child. So this is an example for calculation for based on the body surface area formula. You can try it by yourself. Okay. So by weight is a more commonly used way to determine the dose for a child. So it will depends on the body weight of child, and with reference to the adult dose. Okay, and you can try yourself, and you will see that the dose is also different than the quantity obtained based on the BSA and based on the age of the patient. So but nowadays, usually in the reference book, we would have a standard guide available for most drugs. Okay, most common drug that is used for children, there would be a standard guide available, as the one I explained to you earlier, like the dose for paracetamol, 10 to 15 milligram per kilogram per day. That's the standard dose. So you don't need to determine the BSA of the patient. You don't need to do the calculation anymore. You just use the standard guide dose available for each drug. So as an example, if the body weight of the child is 10 and the drug dose is 10 mg per kg, so it would be 100 milligram. Okay, so the same question, and based on the standard dose, you would get 160 mg per day. So this is much different than the quantity obtained based on the BSA as an example. So let's recap. The first one is the aliquot method. Please familiarize yourself with the aliquot method. You would use them a lot in the lab, okay, and maybe in the exam. Weighing by aliquot and measuring by aliquot is two different things, but they would provide us with an option on how to measure or weigh small volume or small quantity of substances. And the third lesson that you had in this lecture is the pediatric dose calculation. I wouldn't expect you to remember the formula. If needed, I will provide the formula. Okay, it's something that you can easily find in reference book. So I wouldn't expect you to remember such things, because it will not be like something that you would really need to remember in the clinical setting. So I wouldn't expect that. So thank you for your attention. That would be the end of pharmaceutical calculation lectures. I think for some of you, you might find the calculation easy, but for some, you might think this is too complicated. I think it's always best to learn from each other. And if you have any problem, I will be here. Just email me or text me. I will try to help you. Okay? So we will proceed after this with the lecture on liquid preparation. Bye.